USB-C to USB-C 2-meter long cable. The make is Xenta. The price online including delivery was $3 US. I'm actually going to check if this is full feature USB-C to USB-C. On the image it wasn't actually braided, it was plastic layer outside, plastic cover, but this is all braided. I don't like braided cables because they're quite stiff. I'm going to open this cable, cut through the braid here. I'm going to see what is inside. So I cut through the braid, some form of rubber neoprene cover for the cable. So to me it looks like this braid is really done for decoration. I'm going to open right now the rubber to look inside. We can see the braid and the aluminium foil, so it is properly screened. We've got inside the cable, I fully open it, and there are 5 wires. So with this USB 2.0 protocol, there is red and black. They are slightly thicker, and I think they probably represent charging, so V-bus and ground. And then we have green and white that are likely to represent D plus, D minus, so differential pair for USB 2.0 protocol. And then there is yellow cable that most likely is for configuration channel for CC. There is no super speed pairs that should be in USB-C cable, so if you buy this cable and you expect this to run anything in alternate mode, like connect external monitor to DisplayPort or anything of that sort, this is not going to work. It's basically good for charging. I think that charging through this cable is going to be decent, and most likely it is going to work reasonably well for USB 2.0 low speed data transfer, but definitely that's not going to be good for full USB-C specification. Well, honestly, that's what I expected from the $3 cable. That's why a decent USB-C to USB-C cable costs more. Cheap and the most basic USB-C to a USB-C cable contains only 5 wires. It may be screened, it may not be screened. It provides USB 2.0 speed, 480 megabits per second. It does not provide any additional data transfer, so no super speed transfer, no alternating mode like DisplayPort or audio transfer via this cable. All the negotiation between two connected devices happens through the CC configuration channel. Cable is unable to identify itself by containing E-marker chip. The step up is the full speed USB-C to USB-C cable, and it contains 10 wires. So apart from the wires we already discussed, there is also differential pair for super speed transmit and super speed receive. There is also a wire for sideband communication for the purposes of alternating mode. And then finally, the most advanced USB-C to USB-C cable will contain E-marker chip, which is a IC containing information about the vendor, about maximum speed and power the cable can handle. And for some protocols, charging protocol, this eMarker chip is required to work properly. The same for alternate mode. It may be necessary for communication. So that's the reason why the price of the USB-C to USB-C cables is so different, and also why some cables work in certain situations and some don't. Based on the external appearance of the cable, it's not possible to tell to which group this cable belongs, what are its features, what speeds of transfer it is capable of, and whether it supports alternate mode or not. This is an example of the website, of the description from the website that I bought this cable from, and you can see the words here like fast sync, designed to work flawlessly with any device that uses USB-C port, supports fast charging. Actually, it says about speeds up to 480 megabits per second, which suggests USB 2.0, but it'd be nice actually to specify this properly. One of the ways of telling what the cables can do is its length. Cables with a full speed usually will have length less than 1 meter. Longer cables are prone to too much noise and may not transmit full speed that USB-C to USB-C can provide. USB 3.1 generation 1 is usually less than 2 meters, and USB 2.0 can be as long as 4 meters. Anything longer than 1 meter probably is not going to give you a good transfer of high-speed data over USB-C to USB-C connection. USB 3.1 can be good for connections, 5 gigabits per second, and USB 2.0, all the long cables that are used for charging and slow standard USB transmission.